Good morning everyone. My name is Dr. Kunal Patel and today in this video we are going to see the practical example of logistic regression, right? So in my previous video we have seen the theory concepts, what is the meaning of logistic regression and how the sigmoid function, what is sigmoid function and all that, right? So today in this video we are going to learn the practical example of that, how this logistic regression is working, right? So first of all we are starting with the example that predicting a person bought the insurance according to his or her age or not. This is again I'm taking all the simple data sets which are easily available on the internet or Kaggle sites for your practice, guys. So you can also find this particular insurance data set from the internet, right? So here in this data set we have two fields. One is age, and according to that the person bought insurance or not. So here 0 and 1. 0 means not, 1 means that person bought the insurance, right? So according to this database we are now going to calculate the logistic regression. So again guys, these are some basic libraries that you have to import. This again I'm telling that this is the configuration line, that if your system, if your screen supports the retina display, then you can use this to display your graphs in a clear version, right? Now again this is my template, that is very simple template for the machine learning. You have to just read the data set, then you have to set the dependent and independent variables, right? So here we have 27 records, right, and 2 fields, right? So age and insurance bought or not. So df.shape, that is 27 2, and if you print df.head 5, then it will print first 5 values, right? Now let's train our model with the use of machine learning over here. So from sklearn libraries we are importing train, test, split. So 4 variables we are going to get after that: 2 for training, x train, y train, and 2 for testing, x test, y test, right? And with the use of, here we are taking 80% of our data for training purpose, right? So this is our training model. So here if you see that I have used first logistic regression. So this is the procedure. First you have to go for the logistic regression, right? Then we are creating the logistic regression object, and then with the use of fit function we are training our model. So here now my model is trained. Now we are predicting the value of x test, right, and predicting the probability also, right? So here these are the probabilities of that particular model. So now let's try to interpret these values. So first of all I am predicting the responses. Predicting the values means for the particular x test values, what are the predicted values. So here you can see guys, 45 1, 56 1, 21 0, 22 0 means if the person is of 45 age, then he bought the insurance, that's why it is 1. If the person is 56, then also it bought the value, it bought the insurance, that is 1. If person is of 21 years, then it has not bought the insurance, that is 0. 22 0, 51, 26 0, right? So yes, my model is perfectly fine and it predicted value is perfectly fine, I can say that. Now let's try to figure out later on to put our evidence, okay, why my algorithm is perfectly fine. So I'm calculating the R-square value, right? So the score value, score is nothing but the accuracy of the model. Then we are also finding the intercepts and coefficients. So here you can see the value, I have 1.0, my accuracy is 100%, 1.0. So whatever value my model has predicted, all the values are 100% accurate, right? So here is my slope and coefficient value. Here again you can see, if I want to display the actual value and predicted value, then both are same, right? So that's why my model is 100% accurate. Now let's try to get the difference between linear model and the logistic model, right? So this is our linear model. You see guys over here that if I print the graph with the use of linear model, then there are some points are missing over here. My line is not perfectly fit over here, right? And let's try to predict the values that with the use of our logistic regression, that this is for the testing and this is for the particular you can say training model, right? So here you can see that at the age about 20 something like over here about 28 or that part, the people has bought the particular insurance, right? So here this is my linear regression line I have drawn, right? So you can get the idea now over here, right? Same way if I check for the testing purpose, then also you can see over here that it shows the person over 25 that age that has bought the insurance, right? So this way you can also graph the particular, this I have just drawn the line for your understanding guys, right? But if you want to again calculate with the use of sigmoid function, so in my previous video in theory concept we have seen the sigmoid function is 1 divided by 1 plus e raised to minus x, right? So that minus x, that is our predicted value. So here you can see we can put the particular equation with b0 and b1 coefficients, right? And here we are calculating the value using sigmoid function, right? So whatever value we have predicted, that we are putting in the sigmoid function, so that will go over here. So e raised to minus z, e raised to minus y, right? And we are returning the y. Now let's try to predict the values. So if the person is of 24 age, then we get predicted value as 0.479. So it's around 0.48. So it is less than 0.5. So here we have binary classification problems, right? So if the value is above 0.5, then it is positive. If the value is below 0.5, then the person is not bought the insurance. So here it is 0.48 is less than 0.5, which means person which has 24 age will not buy the insurance. And if we take a 56, then we have 0.99% is more than 0.5, which means person with the age 56 will buy the insurance, right? So this way logistic regression is working, right? So I hope guys you understood the concept clearly. So if you want theory concept, then you can see my previous video, right? Session number 9, and here the practical solution for that logistic regression. Okay, take care, bye.